Okay, folks, we have workshop 9 for Math 2303. A little bit about Laplace transforms with the unit step function, sometimes called the Heaviside function. And I'm going to go to a whiteboard and we'll take a look at some different aspects of this. The problem of the Laplace transform for a function with different cases, we sometimes need to know how to write that function in terms of its unit step function. So let's say that we have a function which is g of t for 0 less than t less than, let's say, a, and h of t for a less than t. So for this way, we can write this as g of t. And then when I want to get to the second part here, we're doing that part right there, I need to think of it like this. I'm going to turn on the h of t and turn off the g of t. And then I put in the unit step function t minus a. So there is the formula, or the way to handle different cases. And so I'm going to use that in problem number 1, where we have f of t equal to t for 0 less than t less than 2, and it's 1 minus 3t for 2 less than the t greater than 2. So we have this using the above. I'm going to have t, and then I'm going to have 1 minus 3t, turn that one on. It's that part there that I'm turning on, and turn off the t. That's this one. And so this is then times u of t minus 2, because that was the breakpoint for this function. We simplify that, and we get t plus, what's this? This is going to be 1 minus 4t u of t minus 2. Now, in order to use the Laplace transform with the unit step function, the Laplace transform of f of t minus a, h of t minus a is equal to capital F of s times e to the minus as. The trick here is to line up this t minus a with this t minus a. And so I need to change the expression here, and that is, of course, t there, but I have plus, and I have minus 4 times t minus 2. That's what I'd like to have there, but that gives me my minus 4t plus 8, and so I need to subtract off 7 to make that the same. You see that if I expand that out, I get minus 4t plus 8 minus 7, that's 1. Okay, so I put in what I want, because that has to match up with the h of t minus a, t minus 2 in this case. And now I'm ready to write down capital F of S for this problem. That's the Laplace transform of small f of t. And so I get here 1 over s squared, something that you need to know how to do. And so I have plus, and I have a minus 4t. That's like minus 4 over s squared. I treat this t minus 2 as just t. 4 over s minus 4 over s squared was that? Minus 7 over s e to the minus 2s. And there's the right answer for that one. That is certainly a good way to do that. I'm going to just flip the page to go to another page to do problem number 2. And it has a diagram instead, and the diagram looks like this. And so this is the point 2 here, and this is the point 1, 1. This is here's where we are at 2. And so if I write this f of t down for this is the picture for f of t, but I need to write it in terms of cases. And so it is t if for t between 0 and 1. It is t minus 2 for 1 less than t less than 2. And it is 0 for t, that's a t, greater than 2. And so now we write this down using the unit step function. So we'll do that here. F of t is equal to t plus t minus 2 minus t. In other words, I turn on this part right that I'm underlining over here and turn off the t. And so this gives me u of t minus 1. And then I need to turn on the last part, which I'm underlining and doing this part here. Turn that on, I'll put it in, it says 0, and then minus t minus 2 for, and here we have u of t minus 2. And now I need to make these line up. So here's what I mean by that, t plus. And so here I have a minus 2 times u of t minus 1. Okay. And then, so, and then we have a minus t minus 2 u of t minus 2. Fortunately, these things line up quite nicely, so we don't have any adjustment to make. And so here's capital F of S for this. It is 1 over s squared for the t term, and minus 2 over s squared e to the minus s. That's for the part that's right here. And we have minus, and so this is treated as a t, 1 over s squared e to the minus 2s. And there we have this problem solved. And so we will end this video for this problem numbers 1 and 2 and proceed with problems 3 on the next video. So let me just do the recordings here. And sorry, recording, and I'll stop that recording. And